Voy a desactivar el audio, ¿ok?
Ok, perfecto. We are now on live.
Good afternoon. Let's wait a couple of minutes in order to start. Thank you. Well, good afternoon, everybody. Thank you for joining us today in this BTS talk, in which Martin Longobuco will share his vision about artificial intelligence disruptions in healthcare services. Martin has developed a large part of his career in the tech business development field, with experience in healthcare and artificial intelligence projects. For example, he is the CEO and manager of Datalong Healthcare Internet of People. He's participated as technology advisor for Horizon 2020 Empathic Project with health and pharma partners such as Esteve, an international pharmaceutical company. He has participated as expert in Internet of Things, big data, and artificial intelligence on healthcare projects, for example, with the German Sergas y Pujol Hospital. On the other hand, Martin is professor at Barcelona Technology School in areas of big data, artificial intelligence, cybersecurity, and in the executive master in digital healthcare. At the end of this talk, we'll have some minutes to Q&As. So if you want, please write the questions in the Q&A section in this app, and then we're going to read them. Well, thank you very much. And now I will leave the floor to Martin.
Okay, Cecilia, thank you very much for your introduction. Welcome, everybody. Hi, everybody, and thanks to be there. Today is a very good day to talk about this kind of things, as you can imagine, because artificial intelligence and the disruption in healthcare services is maybe one of the most disruptive technologies today. And well, before to talk about the top topic, I think it will be useful to for us to refresh some basic concepts, if it's good for you, because we will talk about this in different parts of this presentation, and I think it would be better to ensure that everybody can understand what we are talking about. First of all, artificial intelligence is an exponential transformation technology. But before to get deep into this concept, I love to remember what Darwin said. Well, Darwin said, I'm not really sure that Darwin said this, but if you Google it, you will find it, trust me. And maybe it's one of my favorite quotes because it describes very well the situation and the real state of this technology. It is not the strongest of the spices that survive, not the most intelligent, but the one more responsive to change. Well, it is a really good quote, and the question is if we are ready for change, if you are ready to be more adaptive, because artificial intelligence is a really challenge, not only for a human being, but for society. Well, as you can see here, if we talk about the exponential transformation, before to understand what is exponential transformation, um, it is easier for me to show what I'm talking about in this graph and this describing functions. We have here a linear function and exponential function. We can consider artificial intelligence as an exponential function, and the perception about artificial intelligence of the human being, we can consider this perception as a linear function. As you can see here, in my belief, I think we are here in this point, and we describe this point as a disruption. The difference between the evolution, the artificial intelligence evolution, and the perception of this evolution from society, from us. And this is very important because what we are waiting for, this kind of new technologies, is absolutely a short part of the potential of artificial intelligence. Let me show you a little story about artificial intelligence. When more or less artificial intelligence burns, it's at the half part of the last century, more or less, and the 50 decade of the last century, and it was something very similar, like tree invert decision process. It means that there was a lot of software full of conditional if then, and then as much as different branch you can program in your computer, as better would be your prediction. And then we call this kind of software as something like artificial intelligence, because you have an interaction between the computer, and this kind of interaction can be considered at the beginning of the half part of the last century as artificial intelligence. But at the beginning of the 80 decade of the last year, there was an incredible step forward because engineers creates, software engineers creates the first learning process, the first machine learning process. The ability to learn without being explicitly programmed before. It means that the computer can learn by itself, and this learning process requires a training process and requires something like testing process before this training process, and it works very well. And there was an incredible huge quantity of different software that runs in this way, but there is not a real evolution until 2010 of this century. And there was the last step forward in this artificial intelligence evolution. The last step forward was deep learning. Deep learning is based on neural networks, and the neural network, the artificial network, is based on the structure is based on the perceptron. The perceptron is something like artificial neuron, and it works together, creating this kind of new artificial network. And the moment that you teach this artificial brain or artificial network, you start to create a new kind of artificial intelligence, in this case based on this deep neural network, and we call this new step, this new software, deep learning. But what we call deep learning. As you can see here, there is a graph on, there is a slide when I try to compare what is a natural network and in comparison with a perceptron. The difference, as you can see, is a neural network is a cell. It's something that is alive at last. And but the other hand, perceptron is an algorithm. It's something that we create into a computer. And but more or less it's a simulation of a natural neuron. It works more or less on the same way. Well, but how it works? Well, a biological neuron in a natural network, the input is received by the dendrites and is passed to the main body of the neuron, and we call this main body nucleus. And in the second step, the input signal is passed on towards axons, which is basically a transmission line towards axon terminals. And the axon terminals are connected to the dendrite of the next neuron. And then this is a process of the biological process to create natural neuron connections, or something like a brain. Our brain is full of this connection. Our brain is full of these cells connecting in between and making this kind of transactions, making this kind of synapses process and transmitting information between different cells, and helping to the brain to process all the information that begins from the environment and process into our brain in order to predict, in order to make actions, in order to live at last. Well, but in a perceptron, we are a perceptron is just only an algorithm. We are talking about a software, and it's a really simple software at last. The person receives multiple input signals at the same as the dendrites in the natural neuron, and if the sum of the input signals exceed a certain threshold, it either outputs or either outputs a signal or does not return an output, depending on the activation function. We will see in a very easy way with this graph. As you can see here, there is multiple inputs coming from different perceptrons to this perceptron. There is a sum process, and in the sum process create a bias. The sum up process creates a bias, and there is an activate function at the last of this process that decides if the signal goes out or not, if activate or not activate this perceptron. It's more or less the same like the natural network, neuron, and it works as a natural neural network. On the same way, you can create an artificial network and something like well, artificial brain. There is a simple neural network, as you can see here. A simple neural network has an input layer. In this case, the red one. The red dots are the input layer. Is where the perceptrons gets the information from outside and connect each one with the second layer. The second layer is the yellow one. We call the hidden layer. In this case, is the middle layer between the input and the output. And the last one is the blue dot. Is the output layer. Is where we get the result of this data process inside. As much as hidden layer we have, as deeper will be our network. I mean, this is the reason because we call this kind of a structure deep learning natural network. Well, what happened? As much as, of course, as you can imagine, as much of a layer we have, as much computer resources and memory we will require, and gets absolutely complex all the process, and it will be really, really difficult to manage a huge quantity of perceptrons on the same deep learning neural network. And it requires a lot of computers working together in order to process all this data, because as you can see here, there is a huge quantity of connections, a bunch of connections between different neurons, and each one requires a specific calculation process. It requires, of course, a lot of computing resources. This is what we call deep learning. This is more or less a way to introduce what is deep learning. Remember, deep learning in this case, we are talking about the way to teach, the way to train, this artificial network software in order to get some kind of results, in order to create a model. As soon as we create and train this model, we can use this model to create predictive tools, to create predictive results, modifying the input process with real data in order to know what will happen if this data is processed into our model. Well, artificial intelligence is inside an ecosystem, and there is a really interesting graph, because as you can see here, there is artificial intelligence, business intelligence, data, statistics, cognitive computing, machine learning, big data. Everything is connected. Everything is part of this ecosystem. Everything, you need at last everything in order to use this new kind of tools, to use this new kind of resources. And artificial intelligence, as you can imagine, needs a lot of data, needs machine learning process, and also needs predictive tools, statistics, etc., etc. And it means that there is made of different kind of technologies working together in order to give us, this kind of skills, and we will use it in order to create models. It means if you want to create models, if you want to create a deep learning network, we will need data, we will need resources, computer resources, we will need computer storage space, and also we will need some kind of software that can help us to create this process. At last, artificial intelligence, as we know today, is just a group of different resources working together and giving us these incredible skills. Well, now let's go talk about what is happening in the healthcare sector. I want to show you what is happening in different parts of the healthcare sector, how the artificial intelligence is now impacting in these different parts of healthcare sector. The first one is diagnosis. Diagnosis is maybe one of the most required sector, and maybe is an incredible, exciting sector for artificial intelligence. I want to talk about this child because it's an example that I think it's really exciting. It's an incredible example about what is happening today in a diagnostics and diagnosis process on healthcare. I think now it's time to talk about artificial intelligence in diagnostic process. But I want to tell you a story about a 6-year-old child who was doing fine, but suddenly he was no longer walking, he was no longer talking, and he saw many doctors, and there was no answer about what happened with him. It was, as you can imagine, really sad because this child is losing day by day a lot of milestones, and the health process was getting wrong and getting bad last, and there is nothing that can help him. They test a lot of different medicines, a lot of different treatments, and there is no solution. And the doctors cannot stop this degradation process, and it was absolutely a really desperate situation, not only for him but even for their parents and on all the doctor staffs. Well, he was referred to an undiagnosed disease network, where they take patients who are undiagnosed and do all genome sequences on them. And using an artificial intelligence model, trying to detect patterns between genes and symptoms, they look at every single one of the 3 billion letters difference from different human beings through USA. They get a lot of data from different universities and different hospitals, and they compare the genes one by one, and they compare the symptoms and what happens if you modify one gene. Or if there is a gene that doesn't work, which is the symptom. And after this process, they detect that this child has had a mutation in a gene that is absolutely unpronounceable name, but I have never heard before. The name of this gene is GTP, cyclodrolase 1, and it takes a bunch of chemical products and turns them into allo neurons to talk with one another. It means that it creates a gene. This gene creates a neurotransmitter, and because this gene is not working good, as you can imagine, this child was really losing milestones very fast. In order to help him, they give a bunch of different components that can be transformed in neurotransmitters easily, like L-dopamine, phenolic acids, etc. And the child got better in a short time. It means that this was the first case in medicine that caught my attention, and to how artificial intelligence is a step forward on diagnosis and can help people in the real world, and it can help doctors to analyze a bunch of data, a huge quantity of data coming from a lot of different people, and with this incredible process into this incredible model made for this scientist. The system model detects exactly which was the gene that doesn't work for this child, and help all the doctor's staff to create a treatment that can help in a very fast way to this guy. And now today this guy is absolutely normal. The only that he has to do is to eat special food in order to make the balance between this gene deficit with special food to help him to create these neurotransmitters, and to, in this case, to stop this degradation and to get better, of course. I have here another incredible good example about diagnosis. In this case, there is a skin diagnosis. It means that, there is another example about how an artificial intelligence algorithm can evaluate and scan image to diagnose serious skin cancers, including melanoma, and really dangerous cancers like this. The question is, can skin cancer diagnosis be transformed by artificial intelligence? Well, skin conditions, especially different types of cancer, are really common, are really dangerous and really common. Yet the number of dermatologists is fairly low. There is no too many specialists that can help us in this kind of illness. Dermatology is a specialty suited, is a really specially suited for artificial intelligence research and potential incorporation in clinical practice. Because maybe one of the bigger branch of artificial intelligence is applied in order to process images, and artificial intelligence has the potential to decrease dermatologists workloads, eliminate repetitive and routine tasks, and improve access to the dermatological care in order to help them to detect in a very fast way if something is wrong in some kind of modes like this. And this is we will see this application in a few slides forward, and then you will see that this is really interesting and it works very well. Okay. Well, this is the last example in diagnosis, and I think it's a really good example. And the question is how to detect using artificial intelligence, using deep learning model, how we can detect a brain tumor. How we can detect the brain tumor. There was a hackathon maybe a couple of years ago between maybe the best specialist in brain tumor, brain tumor illness, and an artificial intelligence model working together in order to make something like a hackathon between them, a competition between them. And in this video describes very well what happened in China when they test this model in a competition with really good specialists in China. If it's good for you, I want to show it.
疲劳，它稳定。这个工具给临床换来的作用，可能是过去历史上其他工具所提供不了。所以我也希望通过这场比赛，让更多的临床医生和更多的百姓伸出双臂去拥抱人工智能。
Okay. Well, as you can see here, it's an incredible tool. It works very fast, only 20 minutes to detect and to process a lot of huge quantity of different scanner images, and it works very well. This is what is happening today with artificial intelligence in this kind of diagnostics. It's really interesting. And what happened in research? Well, maybe the AlphaFold project is the leader, the top of this of the application of artificial intelligence in research. AlphaFold is an artificial intelligence program developed by Google DeepMind, as you can see here, which performs predictions of protein structures. And the program is designed as a deep learning system. It means that they create and they feed with a lot of data an artificial intelligence model in order to know which is the folding process of the protein. And it is really interesting. As you can see here, there is a CASP, critical segments of structure prediction, and in green there is experimental results. It means that the real result. And in blue, you can see the computational prediction. As you can see here, there is a short object. I want to show you with the pointer. There is a short offset between prediction and reality. And this is what happened on 2018. But as you can imagine, since 2018, today the process will improve and modify and create new algorithms and was fed with more precision data, and the result was better in the last CASP competition on 2020. Well, the question is, why proteins folding matters? There is a short video that helps you to understand what happens when you can predict the way that a protein will be folding, and how we can use the protein structures in order to help our immunity system to attack virus, and even to attack some cancer cells or many kinds of different infections, and can help us to do many different things. This short video will show you how it works and why this protein folding matters.
Inside every cell of your body, billions of tiny machines are hard at work. They carry oxygen in your blood, let your eyes detect light, and even make your muscles move. These machines are proteins, and they underpin every biological process in every living thing. Each protein has an intricate 3D shape that defines what it does and how it works. We know of over 200 million proteins and counting, but we only know the exact 3D shapes of a fraction of these. Unravel a protein, and you'll see it's like a string of beads made up of 20 different types of amino acids. Interactions between these amino acids make the protein fold, as it finds its shape out of almost limitless possibilities. For decades, a community of scientists have been working on a way to figure out a protein shape just from its string of amino acids. This is a major challenge in our understanding of biology. So we created an AI system to solve this problem called AlphaFold. It's trained on the sequences and structures of about 100,000 proteins, painstakingly mapped out by scientists around the world. Today, it can accurately predict a protein shape just from its sequence of amino acids. AlphaFold's predictions could enable progress in all sorts of areas. Imagine a future where we can understand diseases more quickly and develop drugs to fight them, or one where we could use enzymes to break down plastic waste, or even to capture carbon from the atmosphere, all with the help of proteins. There's a lot more work to be done, but unlocking the shapes of these building blocks could help scientists better understand the natural world, and perhaps expand our knowledge of life itself.
Well, as a summary, it means that it will change everything. It will change all the treatment. It will change it opened new possibilities to fight against illness, and even to create new kind of products that help us to control many different things, and it will change everything. Sorry.
Inside every cell of
Okay, as you can see here, there is a result in comparison with what happened until 2016 in the CASP number 12, and what happened in 2018 when appears self-aware and into this new competition process. And what happened about the prediction, about the result of the prediction, considering 100 a full prediction and an exact prediction between reality and the prediction. This comparison in 100 means that is absolutely certain. And what happened in CAPS number 14 in 2020. It arrives more or less to the 19% of success, and we can consider it something absolutely disruptor, and this is the result of applying artificial intelligence in this kind of research process. And what about new business? Well, there is many different business. Maybe I will show you a couple of examples of new business. The first one is this example blow my mind because it's absolutely incredible, and this is a prediction model based on your poop, and it's absolutely incredible, but it works, and it's something that is based on artificial intelligence process, and I will show you how it works.
Carmen is about to go on her second date with Mike. Mike is excited and has been cooking for hours. But Carmen, worried about her gut sensitivities, inquires about dessert. And Mike says,
"Oh, that's apple pie. That's my grandma's recipe."
Thankfully, Carmen has Augie, a digital gut health coach that uses AI to predict Carmen's gut symptoms. Augie empowers millions like Carmen to get back control of their gut health. Bon appetit, Carmen and Mike.
Oh, this is really fantastic, but how it works? Well, the process is very simple. It's just only an app, and behind the app, there is an incredible artificial intelligence model, really good training with thousands, maybe millions of different shit images, in order to create an expert system that works very well. And there is a setup process. You must capture your poop, and in order to classify what has happened. And after this, process, there is a result that helps you to modify your diet, or to modify the way that you take coffee or whatever you want, in order to protect and to get better and to improve your health. And it's absolutely incredible. It works very well, and it's based on a lot of, maybe millions of different images around the world, the people that collaborates with this incredible data set in order to help this artificial intelligence model to improve and to get more accuracy on the results. But even this kind of technology has a challenge. The challenge of this technology is a wombat. What happened with wombat? Wombat is like a little mouse in Africa, in Australia, and it's a challenge for artificial intelligence model, for this artificial intelligence model. Why? Because this is the wombat poop. The wombat poop is like a cube. It's absolutely disruptor, and this is something that you can find it on the natural behavior. In the natural environment, and it's absolutely amazing. It means that there is a lot of work that we have to do before to create a really good artificial intelligence models that help us, not only human beings, but even for animals. There is another one in business, the skin vision. Skin vision is we talk about it, can detect using your mobile camera, and behind this application. There is another artificial intelligence model that can help you to detect if your mole is a melanoma or is something dangerous for you. You take a picture of your mole, you send this picture with your mobile to this service, and then this service use this artificial intelligence model in order to give you an analysis of your and a result, a very accurate result about what happened with your mole. And there is another really interesting new business based on artificial intelligence and healthcare. But there is some areas of impact that we have to consider in healthcare. The first one is the chronic care management, self-care, prevention, wellness, triage and diagnosis, clinical decision supports, even care delivery. There is a huge quantity of applications that are waiting to be created based on these artificial intelligence resources, and an incredible huge field, and when you can find a new business and a new way to help people to get better. And about the challenge of artificial intelligence, the challenge of bias in artificial intelligence models are really important, and we have to consider this bias as something really interesting, and we have to be careful with this. What is a bias? Well, there's many different bias that can affect to artificial intelligence models to not to work in a right way, or even to give results in the wrong way, or bad results at last, or even with no enough accuracy. There is a sample bias made by data, measurement bias into the data set that you use to fit these artificial intelligence models, exclusion bias, algorithm bias, and even prejudice bias inside this machine learning, and sometimes inside this deep learning tools. There is an example here about what happened with the bias. I think it's really interesting to watch this video, because in this video explain what happened into a bias, into a data bias, and which is a result of this bias when a machine learning process gets all the data from a data set that has a big bias. Let me show you the video.
Hi, I'm Joy, and I research how computers detect, recognize, and classify people's faces. In my TED featured talk, I spoke about my experience with the coded gaze, my term for algorithmic bias. The system I was using worked well on my lighter-skinned friend's face, but when it came to detecting my face, it didn't do so well, until I put on a white mask. After my talk was posted, I tested my speaker image profile across different facial analysis demos. 2 of the demos didn't detect my face. The other 2, well, they misgendered me. The demos didn't even distinguish between gender identity and biological sex. They just provided 2 labels, male and female. Now I wanted to see if these results were just because of my unique facial features, or if this was something that was more of a pattern across other faces too. So I began a project that became my MIT thesis, Gender Shades, or the long title, Gender Shades, Intersectional Phenotypic and Demographic Evaluation of Face Datasets and Gender Classifiers, or just Gender Shades. I wanted to see how well different gender classification systems worked across different people's faces, and if the results changed based on somebody's gender or their skin type. I created a dataset of over 1,000 images of parliament members ranked among the top 10 in the world based on their representation of women in power. To get at a range of skin types, I chose 3 African countries and 3 European countries so I could see how the system performed on lighter skin and darker skin. Then I chose 3 companies to evaluate: IBM, Microsoft, and Face++, which has access to one of the largest datasets of Chinese faces. So now with the dataset and the companies, I decided to run a test. The companies appear to have relatively high accuracy overall. Microsoft performed best, achieving 94% accuracy on the whole dataset. All companies performed better on males than females, and all companies also performed better on lighter subjects than on darker subjects. When we analyzed the results by 4 subgroups, we saw that all companies performed worst on darker females. IBM and Microsoft performed best on lighter males, and Face++ performed best on darker males compared to the others. IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. I was surprised to see multiple commercial products failing on over 1 in 3 women of color. In fact, as we tested women with darker and darker skin, the chances of being correctly gendered came close to a coin toss. While more research is needed to explore the specific reasons for the accuracy differences, one general issue is the lack of diversity in training images and benchmark datasets. Failure to separate accuracy results across traits like gender and skin type also makes it harder to identify differences. Companies should do better with commercially sold products, especially since the machine learning techniques that have made gender classification possible are applied to other domains of computer vision, like facial recognition, and other areas of artificial intelligence, like predictive analytics. Predictive systems can help determine who is hired, granted a loan, or what information a particular individual sees. These data-centric technologies are vulnerable to bias and abuse. As a result, we must demand more transparency and more accountability. We have entered the age of automation overconfident yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine neutrality. The coded gaze reflected in the Gender Shades project must be faced.
Really interesting situation, and a really interesting example about how bias can affect artificial intelligence, and the way that we have to be careful with this kind of bias, and we need to supervise, we need to test before to use some specific databases that will fit our predictive models and our artificial intelligence and deep learning models. And also, as you can see here, there is another example. Man who is cooking now is identified by this artificial intelligence model as a woman. It's another kind of bias, it's a gender bias, and this is something really dangerous, and it's something that is happening also into healthcare sector. And what about the future? Okay, well, in my opinion, there is an incredible future, and we can see in China, there is a ping and good doctor, kiosk that helps people to make the first diagnostic of some different illness in a very short time. Behind this machine, there is an incredible huge quantity of data and artificial intelligence model that creates a huge network in different parts of China, and predicts what kind of illness you have based on on this artificial intelligence model. The first implementation of these resources, of this kind of artificial intelligence cabins or healthcare cabins, wherever you want. It was in Wanqi in the south part of China, and as you can imagine, now there is like more or less over 300 million users that they are working day by day using these resources. It means that this artificial intelligence model has a huge quantity of data, and it means that this model can be more accurate day by day, because there is a learning process. This learning process never stops, and helps everybody to make this diagnostic process better and better, get better and better. And robotic surgery and artificial intelligence in the future. I think artificial intelligence is being applied to surgical robotics very fast. Manufacturers see the need to use deep learning data to automate rather than behavior programmed by an engineer that does know all the scenarios. This keep machines learning data is collect from watching surgeon performs, and thanks to this data and complex algorithms, artificial intelligence can determine patterns within surgical produced to improve best practices and to improve surgical robots control accuracy to sub-millimeter precision is absolutely amazing. Artificial intelligence is also being used with machine visions to analyze scans and to detect cancer or cancers, and laparoscopic video analysis of surgeries like sleeve gastrectomy procedures. It helps to identify missing or unexpected steps in real time. It is absolutely awesome and amazing, and it works very fast. If you combine this technology with 5G technology, remember that 5G technology has no latency. It means that you can manage these kind of robots remotely, even in China, and you can make your real surgery here in Barcelona, and there is no latency. And all this process can be helped by artificial intelligence model that helps the doctor to be as much as accurate as possible in order to help them to make the best surgery process. And what about the future? What about the classical computer and about the quantum computer? Well, it is something that it's really exciting, because as you can imagine, a classical computer as our computer today, if you compare with quantum computer, is more or less the same that we compare this abacus versus maybe the most powerful computer around the world today. It means absolutely change of everything, and if you combine these technologies in between, it means that you can have more or less than unlimited computing process and unlimited storage resources, and you can create maybe something that can be called with like a disruptive moment. Everything will change when these technologies can work and last together. And this is something that in the very next future, I don't know if in 5 or maybe 10 years from today, we will see this kind of combinations, and we will see the result of this combination. And in my opinion, in my belief, it's absolutely amazing, and it will change maybe all all our expectations about artificial intelligence and the future of computing. There is, as you can see here, there's more examples that in healthcare is a growing sector, and there is more examples like robot-assisted surgery, virtual nursing assistant, administrative workflow assistance, fraud detection, dosage error correction or reduction, or connect machines, clinical trial participant identifier, preliminary diagnosis, and automated image diagnosis. There is a lot of different areas where you can apply these technologies, artificial intelligence technologies. And artificial intelligence represents a significant opportunity for economic growth of the healthcare sector, of course, and even with the introduction of artificial intelligence into the healthcare sector, there is an expected on 2026 value of maybe $150 billion of economic growth in this sector. Is absolutely awesome, and I think it's maybe one of the most important revolution and most disruptive technology today, and I think it's the consequence of the application of artificial intelligence in healthcare. It is not only incredible, but it's also at the same time absolutely necessary. I'm just going to make a little summary about what we see in this presentation. We see some basic concepts. We analyze in diagnostic, in healthcare sector, artificial intelligence in diagnostic, in research, in new business. We study what happened with the challenge of bias of artificial intelligence models, and we'll see maybe a little bit about the future of this technology, of applying this technology on healthcare sector. Okay, thank you for being here today. I really appreciate that you took the time to be here and listen to my presentation, and of course, thanks to BTS to make it possible. Thank you very much.
Thank you, Martin, for your time. We have a question here. Artificial intelligence and telemedicine has any kind of correlation with them?
Telemedicine and artificial intelligence, yes, of course. Of course, there is a really good correlation between them, because in telemedicine, you can get a lot of data. And I think you have to remember that this artificial intelligence model needs data to be trained and needs data to learn. It means that as much as data, as much as a good, quality and high quality data you have on your data set, as better will be your prediction, as accurate will be your prediction. And these models will grow very fast and will learn very fast and be really useful in order to predict in the very next future what will happen with some kind of illness. I think there is a really good relationship between telemedicine and the artificial intelligence models, and there is a feedback between them, and that you can get data from telemedicine, and also at the same time using artificial intelligence you can use these predictive models to help people at home and make the hospitals will transform maybe with this combination in something like knowledge points, and you can receive even in your home specific treatments with this kind of new tools and telemedicine. Of course, there is a big relationship between them, in my opinion.
Thank you, Martin. We have some other questions.
Yeah.
Is a combination of artificial intelligence and wearables big on the market already?
Yes, of course. There is many application. There is a device that can predict a heart stroke, using the sweat of your skin, and determining which is the lactate acid in your blood, and then can determine if you are in risk or not. And this process uses an artificial intelligence models to help to make this diagnostic process. And also there is many devices that can connect via internet to big artificial intelligence models in order to help people to have a feedback with this new kind of tool in order to prevent illness like diabetics or something like this, and can help a lot of people. There is a combination, and step by step artificial intelligence is arriving on the edge. It means that there is some small models that can be run into even to a small computers, and it means that this process will be really interesting, because it's a combination between a huge computers that are processing a lot of data and a computer a lot of data, and at the same time there is a combination with a small computers that can process part of this data even before to upload this data into the cloud systems. And there is a really interesting new models, new business models into this field, of course.
Martin, another question. Is it hard to get access to data, or is it available only for big companies and clinics?
If you mean to get this data for free and with no restrictions, here in Europe it's not really easy, because as you can imagine, there is a lot of laws that protects this data, and this data are considered here in Europe as personal data, and there is a law that protects this data. But you can share your data if you want in an anonymous way. It means that there is many data sets that are fitted with people that gives their data for free, and you can access to this data for free if you want to train your artificial intelligence model. There is many data sets with a really rich data and really accurate data in order to help you to create a really interesting predictive models based on this data. And then this data is for free. Even in Europe, there is a paper on the in some projects in Horizon 2020 that can give you access to this data if you are part of a project, an European project. We want to develop something. The authorities can help you to access to this data and give access to this data in order to help you to create your own artificial intelligence models.
Thank you, Martin. Another one. In your opinion, how important do you think it will it become for healthcare providers to learn artificial intelligence?
How important? How important? It's absolutely basic. It's a mandatory. Otherwise, you will lose the train. There is no way. You have to understand what is happening today on this kind of technologies. I think it's absolutely necessary to teach people to use these new tools and to show how it works and to show the way to get profit of these resources. And there is many resources even for free that you can use even today to create your own artificial intelligence model, and it is absolutely necessary to know how it works because everything in a very short time will pass to artificial intelligence and big data technologies.
Thank you, Martin. Another one. How would you describe the maturity stage of AI image recognition for eye diseases? Do you think the medical community is comfortable trusting this technology to diagnose people?
Yes, even there is an incredible an incredible application. I read the paper a couple of weeks ago that can predict heart stroke or even a brain stroke just only reading your face. Imagine what I'm talking about. It's not only your eyes, obviously. I think it's more accurate if you read your right, but even your face. There is many doctors. I remember when I was young that there is many doctors that can detect even your illness just only seeing your face or watching your face or even watching your eyes. And this is something that it's absolutely incredible, but it works. And there is in MIT they create artificial intelligence model that can predict illness by the eyes or by the scanning, eyes scanning, or even face scanning. And there is an incredible field, and I think it's something that in the very next future will give excellent results and will be used by doctors. I don't know if is a tool that can be used very fast, but it will be used a lot maybe in a couple of years.
Thank you, Martin. And
You're
it
welcome.
seems we have the last question. Oh, we have two. Has AI been applied for diseases like COVID, and how?
Yes, of course. There is a lot of models that are helping, European Commission to predict what will happen with this kind of, pandemics. And there is a really accurate mathematical, predictive models that help them to take decisions. And I think it's now it's in there is a part of a small part of society that can understand this kind of models, very high technology and scientists, people that can manage this kind of tools, but exist. And even if you want to create it, you have tools in internet that can help you to create a predictive model by yourself if you want. Even there is a lot of data that can help you to create this kind of model. The only you have to do is to put your energy to develop and to understand how to do it. And trust me, is something that is possible.
Thank you. What about behavioral science in AI and vocal biomarkers?
And vocal biomarkers. There is a project in DeepMind that are studying these parameters, and there is something really interesting because they are working at the same time on this kind of vocal parameters with machine learning and language processing. And it's really interesting and the way that if you mean to detect some kind of illness with your voice, I think there is a couple of projects working in this way, but I'm not sure which is the result and which is the in this case I'm not sure which is the exactly real state about this kind of applications, but I know that there is many applications that are studying the voice and even the accent when you speak your own language or different language in order to detect your psychological state, your how you feel exactly, if you are angry or if you are happy, or depending on the way that you speak, this kind of artificial intelligence models can detect exactly what happened to you, and it is really interesting.
This participant shared a web, wevoice.ai, AI.
Mhm.
They're
Thank you very
saying that
much.
we're developing this already. Okay.
Oh, fantastic. I will read it. Sure. Thank you
Great.
very much for your contribution.
And I think we have the last question for the moment. What sources do you use to stay informed with AI and healthcare? MedTech trends.
Stanford University, MIT, Harvard Medicine University. There is many different sources. If you want to read, there is a lot of papers that explain, and you can read it. And well, there is a lot of different sources. Now, I think it is very interesting how Chinese people are working in this way. They are investing a lot of money in create new kind of artificial intelligence models, and they are sharing a lot of information, even in internet. It's for free access, and I think it's a really interesting new, new point of view about the artificial intelligence, and combining all the knowledge from what United States is doing and China is doing today. You can have a really good vision about what is happening today in artificial intelligence.
Well, I think that was the last question. If there are no more questions, we can leave it here. Thank you very much, Martin, for sharing your vision, and thank you everybody for participating in this talk. Take care, and well, see you next time.
Thank you very much, everybody.
Thank you.
See you.